Welcome. This is the second video. We've already completed part A in a separate video. Now in this video, we're going to identify all the extreme points, and I should have left a little more here. On your notes, this is fixed already. Let me put this asterisk here. So we're going to identify the extreme points of g of x, then interpret these within the context of this question. Now remember that this is the graph of y equals f of t. And g is defined as this integral of f of t, where the limits of integration here are the number of hours since midnight. So this is 11 p.m. and this is whatever many hours have passed since midnight. So the key to remember here is that the derivative of g, well, the derivative of g is equal to f. And that has everything to do with the first fundamental theorem of calculus. So if you don't see it here, let me work that out real quick. So the derivative of g of x is equal to the derivative of this integral, which is equal to f of x times the derivative, oopsies, of x with respect to x, which is just f of x. Now, since the derivative of g is equal to f, in order to identify the extreme points of g, we need to see where f changes from positive to negative. So from positive, you know what, I should actually write this out. Positive to negative, or when it goes from negative to positive. And that occurs right here. So here, g of x changes. So its slope changes, that is. So g of x's slope changes here from negative to positive. So what would that look like? Here's if, and actually I should do this off to the side here. Let's do this over here off to the side. And so if we were graphing g of x, which we will do in the next part, here's what it would look like here. We know its slope is negative, so it must be traveling downhill. A negative slope travels this way, and then it goes uphill. So I know that it'll look something like that. So what is this? It's a local minimum. All right, so let's go ahead and write this out. So we have g of x has a local minimum at x equals 0, since its slope changes from negative to positive. And really quickly, let me just fix that here. We're going to identify where the slope of g changes from negative to positive. And there's also a typo, not from. Now, within the context of this problem, what does this mean? So within the context of this problem, this means the rate of change, or excuse me, I should say, This means that this tank was actually losing water, which we've already talked about. The tank was losing water. Then at midnight began to fill with water. So here we are, we've identified one extreme point only here. We have a local minimum, and we know it's a local minimum at 0 because the slope of g, so g is changing from negative to positive, and we've identified that by seeing where f changes. Ooh, actually, let's make this easier. There we go. This is why I should rehearse before I film these videos. Clearly I don't. So we're identifying where f changes from positive to negative or negative to positive. In our case, we only have a negative to positive. So that means we only have a local minimum. We don't have a local max. This would give away the fact that we had a local max and we don't have any. Within context, it means that the tank was losing water, and then at x equals 0, which is midnight, it began to fill back up with water. Please keep calm and math on.